I want to thank you all for joining our Climate Connections event. This is the energy edition. We've got a couple great speakers here who have lots of experience and work in the energy industry. They'll be sharing some of the challenges that they see currently where there's lots of opportunity, right? Wherever there's a challenge, there's also a big opportunity. And that's really the outcome that we want to drive from these talks, is understanding between early stage innovators and industry about where more work needs to be done, where opportunities exist, what language and kind of what form those opportunities really live in, right? We want to kind of drive towards great, successful, commercialized technologies, research that has impact in the real world. So thank you all for joining us here today. You might see, I certainly do, a quick poll up there. You know, what is your sector? Are you in research, academia? Are you currently in a small to medium enterprise or an entrepreneur? Or finally, are you just kind of jumping in an industry to be part of the conversation? If you could give us a little answer there, that would be greatly appreciated, because that poll is up, and I will roll on. If you could move to the next slide, please. It is with gratitude and respect that I acknowledge the lands on which I work and play. So I'm in Vancouver, British Columbia, the traditional territories of the Musqueam, Tsleil-Waututh, and Squamish nations. And I really encourage you all to get to know the lands on which you are living and working and playing, and acknowledge the also traditional and ancestral keepers of those lands. What are we going to be doing today? As I promised, it's mostly going to be talking to some industry partners. That's going to be starting right after I introduce our partners for this event. We will be here for an hour. We'll have lots of time to kind of dig into them. If you have any questions, please feel free to put them in the chat. I will try to get to them. At least it will mean you don't forget them. If I don't get through all the questions, you can always bring them up in the breakout rooms. We'll have a half an hour where you can jump in and choose to speak a little bit further with either of our panelists, Will Fraser or Jack Middleton. But you know, also open to have those here in this moderated session for everybody to listen in on. And of course, in case I move too quickly, it'll mean you don't forget your question. That's always the worst thing. You're like, oh, I got a great question. And then 20 minutes rolls by because everyone's in a heated conversation. And then you forget about it because you got sucked into the value of what you're listening to. So don't be shy about the chat window there. A little bit about Foresight. We're Canada's largest clean tech accelerator, and our goal is to make Canada the first G7 country specifically to hit net zero. This is a big goal. It's going to take lots of people working together, including industry, innovators, academia, investors, and of course, government in terms of policies and regulation. We're trying to bring all these folks together. This is one of the activities where we do try to bring folks together. Will is actually from the United States. So it might not be as motivating for him to say Canada hits G7, but what happens is for us to do that, we make great technologies that will help the rest of the world hit net zero as well. So we're going to be exporting some of that technology. Don't worry, Will, you are in the right place. Next slide, please.
We're happy to support the objective. We're not nationalistic in the energy industry as far as development and deployment of new technologies.
Fantastic. And absolutely, industry really knows no bounds. They're headquartered and they operate in multiple countries. And I think that's a great note to kind of realize. Foresight, we really do help early stage entrepreneurs through our acceleration programs. We also drive adoption through working with industry. That's a lot of what we're about. Next slide. Do want to take a moment to recognize our sponsors and partners at the National Research Council Industrial Research Assistance Program. They are so focused on research, it's in their name 2 times. Rob McGarry is joining us there, and he's actually going to talk briefly about the co-innovation program that, again, is all about bringing technology and commercializing it successfully. And Rob, I'll let you take it away from here.
Sure. Thanks, Stephen. And that was a good segue from Will and yourself about, you know, how energy industry knows no bounds, and that's kind of what I'm touching on a bit here. So yeah, I'm with with IRAP, the international group, and our role is really to foster co-innovation and co-development between Canadian companies and global partners. Go to the next slide. Yeah. So again, many Canadian companies already, go global by recognizing that it makes sense to find a partner in a target market that you can work with to redistribute or sell your product, as well as selling directly. But also another great way to grow internationally is to find an actual R&D co-development partner in a market that you're looking to enter. And then the two of you, or even multiple partners, can work together to create a solution together that benefits everybody involved. We partner very closely with Global Affairs, and a lot of our programs that we offer and our PDAs, which is missions, and that are coordinated with the Global Affairs people. Next. So this is our current reach. We've now supported our group about 500 Canadian SMEs, over 160 million in funding, lots of projects, 35 countries. And now with the new announced Indo-Pacific strategy, there'll be additional countries that will be added on in 2023. China, as you know, is on hold right now since 2020, and as well as Russia. We don't do any current business with them. Next, please. So, one of the things that take away from all of this is, and we've looked at our own data, internal data, companies, IRAP clients that have taken advantage of international programs and ones that have not, and there's a difference, definitely a difference, that it does increase your growth as well as it enables new jobs. Go to the next slide. So this is just an infographic. We looked at our own internal data. 77% of all of the co-innovation projects that we funded went into a commercialized product that one or both partners were able to take successfully, and it also led to employment growth and export growth as well. Next slide. So the type of partners that we bring into these programs, they're typically targeted. The IRAP side targets SMEs, but we also get involved with ones that involve large foreign M&Es, universities, and research institutes in Canada as well as abroad. So I'm just going to walk through now a very simplified view of a co-innovation journey and kind of show where Foresight, the program that Foresight partnered with us to offer, it kind of fits in the whole picture. Go to the next slide. So we kind of look at it as the ACE approach. There's the assess, where as a company you're trying to assess whether this co-innovation is something you want to consider, and whether you're ready for it. And this is where Foresight, the program, the Global Co-Innovation Clean Tech Program, it facilitates that kind of assessment with companies that are at a certain stage, and they're looking to see if this is something for them, and also how they would proceed about going to do it. And we provide some funding to help them do that. Once they've done that, they would then go to, they would start connecting with partners. There would be some matchmaking events, maybe go on some missions and all that. And then finally the execute, and that's kind of our bread and butter, is now you're at a stage where, we found a partner, and now we would like some further funding, larger funding, to actually go ahead and implement what we've agreed with our partner. And that's where we offer quite a large amount of programs that support that well. We fund the Canadian side, and our partners fund their side of the equation there. Next. So this GCCP, again, it as I described before, it allows the SMEs with a clean tech focus to look and put together a plan on how they're going to go about either finding a partner, or if they've already got a partner, how they take it to the next level of that partnership. Next slide. It's a 2-day kind of workshop, virtual workshop. The first day is where the hosts, the Foresight has hosts, IRAP provides some hosts as well, and it'll go through your different global value chain and market access models, get clients to kind of identify the company that they feel they need, the gap that may be in their technology that they're trying to fill, and put together some direction in that area. And then the second part is to actually, the second day is to get together and build this plan, and you actually create an actual strategy that is reviewed. Okay, so that's kind of part one, which is this 2-day workshop. Then the second part is we actually fund that strategy up to 30K, and then you would execute that strategy typically within the next 3 to 6 months. Either identify a partner, take that partnership forward and move towards scoping out a project that you could possibly do together. So those are really what we try to do here, is to kickstart a co-innovation plan for Canadian SMEs. Next slide. And these are the typical things that are covered by this project, but it's not comprehensive or complete. Market studies, competitive analysis, business model modifications, maybe a go-to-market plan, any kind of IP guidance that you need. There's some travel. We cover the travel in order for you to meet your partners or to seek partners, and even some work on some proof of concept work. The only thing that isn't covered is internal salaries in the company, but everything else, contractors, all that is covered by this funding. Next slide. So what we're looking for, the general guidelines, is we want the company to be an IRAP client. So it's very important, if you're not already a client of IRAP, that you need to get in touch with IRAP and start that process. And they'll look at you from the general IRAP intake requirements, a certain amount of things that they look for you to be eligible for potential funding. The idea is we're also, in addition, looking for companies that are growing, and they're looking to go to a global market in the fashion that I described through co-innovation. We want to make sure you're sufficiently resourced, so they don't want to have a situation where you're pursuing an international opportunity and it kind of blows up your company because you're all in on this international and your current revenue falls apart. The guideline is really to have 7 to 10 employees minimum and about 500K in revenue. There are some exceptions there, but that's generally what we look at. Just to give you an example, we have a similar program internal to IRAP that's been successful, and that's why we're looking to expand it and effectively franchise it, if you want to use that word, to partners like Foresight, who can bring their expertise, their clean tech expertise into it and really add some value. But in the past, we've worked with over 100 SMEs with about $3 million in funding just to get them to the execute phase, and then we've had some that have been successful in those larger projects that I've talked about. Next phase. So that's really it. Basically, the next steps is to loop back with Foresight and find out when their next cohort is, and see if it's something you'd be interested in doing. And clearly, you can obviously reach out to me as well if you have any particular questions about the IRAP aspects of it. That's it. Thank you.
All right. Thank you very much, Rob. So you're going to hear about some opportunities in the energy space today. You're going to take solutions that you have and adapt them to these problems. We're going to develop new solutions to these opportunities. And then Rob McGarry and the IRAP team are going to step in and provide some supports. IRAP, if you don't know that organization, he mentioned you have to have an ITA. If you are developing solutions in Canada, certainly some folks that you should reach out to and learn more about. The co-innovation program is a fantastic opportunity to partner, because really, as I said off the bat, we need to scale solutions outside of Canada. We just can't be solving things for our neighbors here. We're only 40 million people. We need to be solving problems for the other 7 billion as well. And I think that's a wonderful opportunity for enterprises. It would not be bringing academia into the picture if we did not have some of our friends here from E@UBC. We've partnered with E@UBC over the past year on this program, and more recently SFU and UVic, and we'll be bringing on more academic partnerships. But Shannon Bard, I will turn it over to you to tell a little bit about the Climate Venture Studio at UBC and what you see this folks getting out of this.
Fantastic. Thanks so much, Stephen. So Stephen and I started this over a year ago, and the idea is we had identified that one of the biggest challenges we have supporting scientists and ventures, especially those coming out of universities, is giving them an opportunity to really explore customer discovery with people from industry. Often their existing network doesn't include people from industry. And so I lead the Climate Venture Studio at the Entrepreneurship at UBC program, which is a program in Innovation UBC to help support launching ventures and doing research translation out of the university, particularly focused on climate solutions. I think there's a second slide that comes up after this. that we can move to. And really what we're focused on is how can we shorten the time frame between the inventions and actually adoption in society. So the historical data suggests that it takes on average 30 years between actually inventing something in the lab and getting it adopted in society. And if we want to actually make an impact in meeting some of our targets that we have around climate, we need to change things up. We need to do things differently to be able to do that faster, to get pilots run, to de-risk new technologies and get them adopted by society. And so part of that process is really understanding what is the market demand and getting more access to potential customers and industry to really understand whether the hammer that you've built will actually solve some problems for the nails that are out there. And so that's what this sort of reverse pitch climate connections events that we've developed is all about, is getting opportunities to hear from industry what are their most urgent pressing problems, and to give researchers and our research entrepreneurs an opportunity to ask questions and to really see whether they might need to adjust their approach for where there might be a more immediate market opportunity. I think there might be one more slide after this, Stephen. And so that's really what our focus on here is at entrepreneurship at UBC, is on really helping with this research translation piece. And not only do we have support for climate solutions, we also support health solutions and social solutions. And we have teams that actually overlap in all three of those areas. So thanks very much, Stephen, and I hand it back over to you.
Thank you very much, Shannon. And I think that ultimately is why we're all here. Shannon doesn't want to wait 30 years for your solutions to make it a market. Will doesn't want to wait 30 years. I know Jack doesn't want to wait 30 years, and you shouldn't want to wait 30 years either. Let's make this thing happen a little bit faster. With that, I've teased you with them for a little bit here. We've got two wonderful guests. Will Fraser, who I've mentioned already, lots of experience in the energy industry, decades of experience. In fact, he's worked with Chevron, he's worked with Freeport LNG. He's here today to talk a little bit about some of the challenges that he's seen in that industry. He's led projects. Will, what have I kind of missed out on your background there?
Well, that covers a lot of my background. I've worked quite a bit internationally, so my perspective is broader than a North American perspective. And I've worked in technology development and in health environment safety management. So I bring that perspective also to my work with Unique Ventures. And Unique, of course, is trying to look for new technologies, look for new technology startups that need some additional assistance in order to successfully commercialize their products and services.
Awesome. Excellent. Our other guest is Jack Middleton. We haven't heard from him yet, so I'm super excited. Jack is the community engagement advisor for the Canadian Association of Petroleum Producers. I say that slowly so I get all those syllables in there. And really, they're focused on Canada's upstream oil and gas industry, right? And making sure that there's responsible growth there. So there's tons of opportunities, I think, in that area. You know, he's worked in the natural resource sector, in public affairs and government relations. And so happy to have him here today to sort of represent some of what that industry is looking for. Jack, what have I missed out? What key salient points would you like to share?
Well, I don't know if you missed out on anything. That it is a bit of a mouthful, but we just call it CAF. I guess the big thing I'd say is that we represent production from coast to coast. So there's offshore oil production in Newfoundland, there's the oil sands in Alberta, and then natural gas in BC. And that's really what I'm focused on and kind of what I'm going to talk about today.
Wait, Jack, isn't there like some traditional oil production in Saskatchewan as well? Let's not forget our prairie brethren here.
I'm so sorry for passing over both Manitoba and Saskatchewan. And, apologies.
I'm just teasing you. All right, let's dive in here. Maybe we'll just, unless there's slides, do you want to just turn the slide sharing off and we can just focus on our wonderful guests here? Will, what did you want to talk about? You've come today with a few areas of specific interest where you see challenges for the industry. If I can, I'll give you the floor and you can talk for a little bit about what's bothering you and where you think somebody should fix something.
All right. Well, that's what I call a short question with a long answer, but I'll try to be concise. Certainly, Unique Ventures has enjoyed our existing our previous partnership with Foresight Canada through the Energy Next program to bring new startups along and help them to develop their business plans and get traction in the market. And the question is always, well, what kind of technologies or what kind of startups are you looking for? And we try to look at those that we think match the needs of the mid-scale energy producers that we work with on the other hand, who want to integrate new technologies into either their existing businesses, which may involve the kind of hydrocarbon production that Jack's consortium is involved in, but also those that are trying to grow new energy businesses as they come along. And so we've identified a number of technology areas that we're focused on finding those startups in. One of the first, of course, is the low carbon solutions area of trying to reduce CO2 or methane emissions from existing production, find ways to capture CO2, and also, of course, the big opportunity in carbon capture, utilization, and storage, of which Canada, of course, has been a leader in some areas, and there's a lot of opportunities in the Canadian geology, if I can use that term, for CCUS. And then companies are also broadening out into what you call the energy transition area, where they're looking at new fuel technologies like hydrogen, like renewable fuels, but also with the focus on shifting to electrification. That includes both more novel ways of electricity production besides conventional thermal power plants, and energy transportation and storage, because the storage conundrum is critical if we're really going to shift to large scale electricity production from intermittent sources like solar and wind. Now, there are other technologies that really apply across to both conventional hydrocarbon fuel and production and novel technologies. That's the new materials and manufacturing processes, handling waste in a fashion that hopefully recovers some value and minimizes the waste footprint. And then all the digital technologies in terms of both asset optimization and use of artificial intelligence, and also the use of autonomous solutions. There's a lot of technology, of course, going on today with drones and autonomous devices, but that also includes new sensor technology to better monitor and control processes, augmented reality techniques for better management, and novel ways to operate remote facilities. So there's a whole world, both in the digital technologies, but also in the process and mechanical technologies, and we scout in all those areas. Now, for conventional technologies, we do look for technologies that are more in the technical readiness level 7, 8, and 9, where they're ready to go to pilot or ready to field trial. That's one of the places we think we add specific value. But for new energy technologies and clean tech, we need to look a little earlier in the process. So more like technical readiness levels 4, 5, 6, maybe 7. And for the real game changers, the highly novel technologies, some of those come out of the Department of Energy labs here in the US, some of them may come out of the research labs in the universities in Canada. Those need early industry support and validation, even if they're before the proof of concept stage. And so we might even get involved helping a company or a venture at TRL 3 just to help them understand where the business needs are. So that's a quick survey of where we see some opportunities and interests, and happy to talk about those in more detail as time and interest permits.
Okay, absolutely. Will, thank you so much. Jack, how about yourself? Over to you. What are you sort of seeing on your end? And is there a few specific areas you want to jump into?
Yeah, absolutely. I wanted to talk specifically about BC and natural gas production here. I think maybe some of you have heard a lot about the Pathways Group and the upstream and the oil sands. I'll leave that sort of space to them. There's a lot going on there with CCUS and all of that kind of stuff. But for natural gas in BC, there's actually a huge opportunity from electrification. You've probably heard a little bit about this from the LNG facilities in the downstream. And I'd really say the opportunity is flowing Canadian natural gas to LNG facilities that are able to export internationally. There's the LNG Canada facility that's under construction today, and recently we saw the Cedar LNG project approved by the government. But with that came a set of conditions, including a cap on emissions, which is in line with the targets that they'd set for 2030, and then net zero by 2050. And so I think you're seeing our industry working towards those goals, and some of those facilities actually specifically looking for natural gas that's produced with a lower emissions profile. And so one of the facilities I wanted to talk about, and one of the things that kind of highlights the opportunity here, is the ARC Resources Dawson Creek facility, which they built to have electric drives and run off of hydroelectricity from nearby sources. That actually was able to reduce a significant amount of emissions. And likewise, Avintiv, another Montney company that has built or retrofitted their Saturn, Sunrise, and Tower processing plants to use electric drives. This reduces emissions significantly, but I would say, and I guess it also has add-on effects. It reduces the noise pollution from facilities as well. But as we get out to more and more remote facilities and the wells themselves, we find that it's harder to electrify. These are smaller scale things. They're running off of generators, and they're not permanent facilities in a lot of cases. So that's sort of the challenge I wanted to highlight, that maybe something in the upstream in the oil sands that's built in, that's there for decades and a significant amount of time, is an easier thing that you can build in infrastructure around. But these wells and these sites have a shorter time frame to them, and so we've seen a lot of work done by members to electrify the processing facilities, but it's a larger challenge out here. But the opportunity is there. We see the hydroelectricity makes up the majority of BC's grid. And then I wanted to just highlight quickly, to that international challenge, to that Canada, US challenge. The United States recently put forward the IRA, the Inflation Reduction Act, and it's challenging. It means that we're seeing leakage of technologies and things like that abroad. So our organization, one of the things that we've pushed for and we're pushing for is shorter regulatory timelines on facilities, whether that be clean technology facilities or otherwise. We think that's maybe a place that we can win, because it's unlikely that Canada can match the sort of might of that bill. And maybe people will disagree with me, that's fine. But I think there's an opportunity there for us to work together and to make sure that Canada is staying in the game on this stuff and using that technology where it matters on projects like this.
Okay, awesome. And you're right, that IRA is difficult maybe for Canada to compete with, but also is it an opportunity for Canadian innovators, right, to leverage that and sort of deploy technology down in the US? I did want to dive in though a little bit. So you sort of said they're electrifying the processing facilities, right? The electric drives exist, but it's the real challenge is how do you get electricity out in the field to something that is a temporary installation? What's the kind of scale of this opportunity? You sort of said you want to focus on the BC market. I mean, are we talking about like hundreds of wells, thousands of wells, tens of wells? What is this? Is this going to be a super common? So somebody spends some time to develop something that can generate the power, remotely, or cheaply lay transmission and distribution, which that's not a reality. But they solve this problem. How big is the market?
That's a good point. It is definitely hundreds of wells at this point in BC. There's potential for thousands across Canada, I suppose, in Alberta as well. But it is, I think one of the additional things to think about is that there are multi-directional, multi-well pads that have been developed by a lot of these companies. And so they're trying to centralize a lot of the drilling onto those pads and do some of that work. So maybe it's not thousands of facilities, but it is it is a very important aspect of the upstream here.
No problem. I mean, sometimes you get that niche, you find a problem, and I think and if the pain is big enough, that's what can drive innovation, if they can pull that through. Will, you mentioned electrification as one of the themes that you see as well. Would you sort of, how would you comment on Jack's focus on that, the electrification of the wells? Is that something that you're seeing down in the US? Is that something you're seeing internationally as a focus area for folks, or is it really still more at the processing plant that they're looking for electrification?
Well, it's really been both. I mean, the mid-scale producers in North America recognize that they need to reduce emissions from their drilling, hydraulic fracturing and stimulation, and production systems out in the oil field, as well as in the transmission, processing, and eventual end use of facilities. So that can take a number of forms. You mentioned that I'd worked at Freeport LNG, where I was the operations engineering manager. Well, Freeport LNG, which is a three-train liquefaction facility built on the U.S. Gulf Coast in Freeport, Texas, so similar in size to the LNG Canada facility that Shell's building there in Kitimat. Each one of those 5 million metric ton LNG liquefaction trains has 3 compressor strings, and each one of those compressor strings is driven by a 75 megawatt electric motor. Now, 75 megawatt electric motor is a big piece of machinery, and this is the first really large scale LNG facility that's been driven by motors. So I think that's the vision of what, for example, the authorities in BC want to see in BC. That rather than seeing gas turbine drives on the liquefaction facility, they want to see these big motors. But all the way then back to the well site, you're talking about electric supply to drive the drilling rig, to drive the high pressure pumps used if you're in a hydraulic stimulation mode, and then all the pumps and compressors used in production. And so you're trying to make sure that's run as efficiently as possible with minimal emissions, and where you can use energy sources like hydro, which BC has abundance, or nuclear, geothermal, wind, solar, ones that don't have CO2 plumes affiliated with them, then you're reducing the overall CO2 intensity of delivering those hydrocarbons to the ultimate market. And there's a lot of interest in that. And it goes all the way down to how you run your control systems and what you can do remotely. If you can avoid having to have what we would call a pumper here in the US, a oil field service tech who has to drive out to the well site in his ute or his pickup truck and burn diesel fuel or burn petrol. And that can all be remotely monitored and controlled. That's another way that you reduce the overall footprint of that operation.
And then I want to kind of ask a little bit, Jack, you said that there was some pressure, and you mentioned, I think, regulatory pressure to reduce the amount of emissions that these organizations are putting out. Is that by 2030? Is that like kind of per gigajoule of energy, and is that going to be hard to meet? I guess, a good problem for me is always a problem where people are willing to pay more for the solution. Like, so whatever they're doing now, they'll say, oh, I need, it doesn't matter what this costs me. We need to electrify these wellheads. Like, if we have to transport hydrogen and generate the electricity on site, or if we have to store it, or if we have to generate, to Will's point, with, small modular reactors, which is both terrifying and exciting at the same time. Is that regulatory shift really driving enough pain in the industry, you think, for them to pay more for a solution than what they're doing today?
Yeah, so to answer that part, we don't have a clear picture of what government has just said with the announcement of the Cedar LNG facility. They announced a number of additional conditions for that project and for the upstream. They've called it a regulated emissions cap. We don't have the details for that. It's at this point just an announcement. But what we do have is their climate targets, which is by 2030, 40% reduction from 2007 targets or levels. And that's really, it's consistent with what they're saying. How they're going to get there maybe will change and they will become more strict. But the reason I gave the ARC facility example is because Cedar actually signed an agreement with ARC to supply that facility 3 years ago. And so, the facilities and the people who are getting their gas are being smart about who they're getting it from. They know that to get regulatory approval for those facilities, that they have to get it from low emission sources. And none of that starts 3 years from now. It starts 3 years in the past. And so these are the groups that have to actually, they're going out and they're getting their offtake agreements from companies that can provide that and have a solution in the window for them. So I guess to answer that question, we don't necessarily know what the future holds on that, but we do know that these climate targets are there, and the ways that governments are going to get to them are probably going to become stricter and more serious. So.
And you mentioned that this was in large part for export. I mean, our LNG facilities are unsurprisingly located on the coast because they're going to ship all this gas somewhere else. And you sort of mentioned that the market wants to buy natural gas with a lower carbon footprint. Are foreign buyers willing to pay more to, support innovative or lower emissions things? Are there Japanese regulations driving what they can import? There are the Korean, the other markets, Chinese regulations that might drive those buyers, or is there just appetite there on the buyer side to support the higher costs that different approaches might take?
I think you hear that sometimes as an argument from Canadians, and somewhat that's the case. But I do think that international buyers, and especially it depends on which countries are buying it, often are looking at what is the cheapest source of this product. So, I not to burst that bubble completely, but it is, I'll give the example that during the Ukrainian war, Europe has been looking to importing natural gas and LNG from Qatar. When they started doing that, it increased the price of LNG internationally. And it also took it away from countries like Pakistan, who were looking to import it as well. It raised the price to a point where they couldn't. So in a lot of cases, what we're seeing is countries like Pakistan are moving towards coal again. And so there is an opportunity to sell that lower emissions molecule of natural gas internationally. And there are countries that want that profile. Japan, Korea are examples. But, being able to deliver something that's close. Canada is one of the closest shipping routes to Asia and to Japan and Korea. And I think there's a huge opportunity from that perspective, because the shorter the amount of shipping days, the cheaper the cargo is, the less that you lose to boil off, things like that. But I would say, when we were talking about the upstream as well, it is a small number of wells, but the opportunity, the scale of it is quite huge. It was $4 billion over the last 4 years went into the BC supply chain, and $2 billion last year for royalties in BC. And so just a small number of wells, there's a significant economic impact to that. I wanted to get that in as well. But then, something like the LNG Canada facility is a $40 billion project. It's huge scale we're talking about with these things. And, the market is there. Like countries like Japan want Canadian natural gas. That's why Mitsubishi is a part of that consortium for that project. And there's a huge market for LNG. It does have to be cost competitive, is something not to lose sight of. Sorry for that long-winded answer there.
No, I think that's a fantastic answer and some good notes on the state of the market. And, again, if the regulations change and drive requirements for the electrification, then I think there's room for those solutions in there. Will, you sort of mentioned that Freeport LNG, they went toward those electric drives, those massive 75 megawatt motors. What was the driving decision there? Was it that lower emissions standards they had to meet, or was it that the electric drives were cheaper and easier?
Well, I can tell you that I've looked at the electric drive solution for LNG multiple times over the years in my work with Chevron and the gas technology area and such. And historically, it always penciled out to be more expensive because of the need to have sufficient reliability in the system. You know, LNG relies heavily on the reliability of supply to the customers. Our valued Japanese customers, as Jack is saying, look to countries like Canada as a great source because they highly value that security and reliability of supply. Now in Texas on the coast, where there's a large petrochemical industry, there's also a very strong electrical grid because those petrochemical plants use plenty of power. And so Freeport was able to choose a location that had a high quality grid, and they didn't have to invest a lot in new electrical generation or transmission facilities. Freeport was also driven by local air quality regulations in the Texas Gulf Coast. When you put in an LNG plant driven by large gas turbine drivers, gas turbines are very efficient and relatively low emission, but they're big and they burn a significant amount of natural gas, and that puts some degree of nitrogen oxides into the air and things like that. And you can combat that with technologies like selective catalytic reduction and things. But ultimately, I think that was a significant influence on Freeport was local air quality permitting issues along the Texas Gulf Coast, whereas with electric motors, you have minimal air emissions. And so it was not the greenhouse gas emissions with their global impact. It was more things like nitrogen oxide emissions with that local impact on ground level ozone, which of course is a regulated pollutant here in the US under the Clean Air Act.
Excellent. I think that's a fantastic expansion. It's not always about money and you know, what regulatory environments are you looking for that will encourage people to pick a new solution that solves one of their problems there. Here we're maybe going to step out of the realm of the known into a bit of the hypothetical, but Cassia has a question. Is there an opportunity for hydrogen to play a role in powering extraction? Will, have you had a chance to take a peek at any solutions that use hydrogen in powering that extraction?
Well, there certainly is an opportunity. There's certainly an opportunity for hydrogen. Whether it would be a strong option for the hydrocarbon extraction side is perhaps less sure. I mean, hydrogen is a fuel. It's not an energy source. You have to have a core energy source to make the hydrogen. If you have lots of hydro or lots of nuclear or some other kind of large baseload electrical production, then you've got the opportunity to make hydrogen and or ammonia as a transportable fuel. There's a lot of interest in either using hydrogen as straight hydrogen or using ammonia as an efficient hydrogen carrier to move basically the hydrogen fuel from one location to another. So there's a significant interest in possibly using ammonia, for example, as an alternative to LNG and shipping carriers full of ammonia, say from Australia or Canada to say Japan and East Asia, and then in effect burning that ammonia, especially design gas turbines or units with, again, no carbon emissions, CO2 emissions. You have to worry, of course, about nitrogen oxide emissions, but there are ways you can manage that. So as far as transporting hydrogen to the well site, you might actually end up using ammonia instead because it's just a lot easier to transport than hydrogen.
Excellent. And I mean, do you see people exploring that? Does that look like a cost-effective solution to get power out to well sites, bringing the fuel to site? Because I know right now, I'm assuming they kind of use burn the fuel that they're extracting is my guess. So it's there's very low of transportation costs, right?
Yeah, that's kind of hitting the nail on the head there. It's something that's available, and for traditionally, like something like LNG, if you were on the north coast of Australia, for example, like you have this big facility. There is no electricity around. There's just the gas that you're getting out of the ground and then shipping, and so that's why those things run on natural gas. It's right there. From like the extraction perspective, I don't have necessarily an answer to the hydrogen specific one, but I'd use this as maybe an example of how you could think about it. And I know that Tourmaline, one of our members, switched from diesel trucks to natural gas trucks as a way to reduce emissions, but also move off of diesel and similar kind of air quality issues there. But hydrogen has been floated as an industrial vehicle use case. There's a significant facility going in Prince George. I know that they had been piloting that for trucks. I saw something about that this week, and so I would say, like, maybe thinking creatively. Like, I don't have a costed model here, a business plan for you, but thinking creatively, there is an opportunity there. But you'd be looking at what could the hydrogen power? What is the actual usage for it? And if you looked at things like the switching from diesel to natural gas from Tourmaline, that's perhaps a good example.
Okay, awesome. We've got a question from James Rowe, and it's a long one, and my eyesight is poor. James, you just want to unmute yourself and ask?
Sure. So one of the big challenges for early stage companies is when they've got a novel technology, it's understanding how it fits into the operational constraints. So when you engage with industry, it's sometimes hard to get in and talk to the operators who have a certain way of thinking about the way that things work. And so I'm wondering, like, what would be some recommendations about how best to engage with industry to get an understanding of the constraints? So, for example, like if you were to switch to hydrogen fuel to do this, what are the constraints within operations that are maybe going to have like additional costs or other things like that might impact the decision?
Well, this is one of the reasons we created Unique Ventures in the first place, is that all of us in the enterprise have many years of experience in the energy industry and have worked in projects and operations and such. So we bring that perspective to the startups with whom we work and try to help them understand those constraints and help them de-risk their technology, particularly if they are planning a commercial field trial and such. But it is important to have a good partner on the industry side to help you to both complete I'll call it the development stage, and also the field testing commercial demo stage, because you want to do this in a way that has maximum chance of success and minimum chance of upsetting the existing operation. Because sometimes you only get one chance. If you make a muck of the existing operation, they're not going to want to have you come back and say, "I want to try it again. Let me have another go at it." So some companies are set up to actually do that. The larger operators will sometimes have groups that do that. I mean, my old colleagues at Chevron, for example, Chevron Technology Ventures, their venture capital arm, they have a whole group within that helps with the commercialization, identifying the application cases for new technology. The smaller mid-sized companies struggle a bit with that. And that's one of the things we try to do, is help them with that, or find a mid-sized company or an industry association that really wants to apply the new technology, and then sometimes they can help serve as that interface. Because the field foreman, the field supervisor, she doesn't want to have her operation shut down because there was some glitch in your new technology. She's accountable for the profit and loss statement on that, let alone if it causes an environmental or a safety incident. So you've really got to think about how to de-risk the technology before you take it out into the field.
Yeah, and that's maybe one of the challenges, is you need to have the technology be mature enough to have that engagement to do your field trials, but you can't get and have a conversation with the operators to understand the constraints until you have that maturity. So there's this chicken and egg problem that I'm wondering if you have any recommendations about how to kind of address that.
think from our
Jack, do you have any comment from the standpoint of the folks you work with?
yeah, I think from our industry perspective, like our members have tried to create a few different organizations to tackle this kind of question and have that commercialization piece. There's a PTAC, which is the Petroleum Technology Alliance Canada. And there's one that I'll put in the chat as well called the NGIF Emissions Testing Center that was led by Tourmaline. And that's really about methane. So they've actually got a facility that's really meant for testing and this sort of scaling of technologies around methane. And so, I mean, I think what you're addressing is that gap, right? Like the taking something from that research base and scaling it up. And so that's always been a challenge. I'm sure this is something that Foresight does quite a lot of, but I would also ask you, like I'd put it out to you, what do you think would be effective in reaching out to members and engaging them? Because you're right, like they would want to see something that's at a scale that they can implement, but they're not necessarily that early on. We have some members that are really active in this space, and then we have some that just they don't have time to get into that.
Yeah, and I think, Jack, that's where when I was asking around what's the size of the problem, and how burning is it driven by regulatory change, they need to do something now, or the market is still really very cost sensitive, and so they're not going to want to do anything more expensive. If you can find those people who have there's a wonderful turn of phrase used by one of my colleagues, a bleeding neck wound, right, then they will do whatever they can to save their lives. So if regulation is really driving a change, or there's something in the market where they're going to be outcompeted, then they will be interested in talking to early stage innovators and will be motivated. And with everything, there's a bell curve, right? There's people who are going to be early adopters and early innovators, and there's people who are going to be the last in line to take on a new approach, right? And so you do have to find the one. So Jack, you sort of said some of the folks are going to be busy executing and they're not going to want to play, and some of them will be just designing a plant and saying, how can we really do this the best way? And so it was great that you highlighted the Cedar that was just approved. They've apparently worked on the ARC resources one, so they'll probably be using electric drives there. But are they going to be looking for a couple innovative solutions that have been tested somewhere else versus a plant that's already operating? Those are tough ones to get into. So that is absolutely a tough hurdle to overcome. There's a question here from Jen regarding accountability and around how these things are tracked, how the outcomes of this are done, and is there a requirement for any innovation around that, right? So it's nice to say that electric drives, and in that case maybe it's really obvious, but are there other pieces as you put things out in the field, as you implement new approaches to actually verify how much better they were than the old approaches? Do you see a need for innovation in that area?
See, this includes like a reference to their equitable origin, their certification as well.
Mm-hmm.
And I would just add like that's a voluntary process that they undertook because they felt it gave them an edge in ESG markets. Without speaking for the company, I know that's the direction that they went for that. There's no requirement for that in Canada. Other than the regulatory environment that exists around drilling a well. So I'd say like there's not necessarily government hasn't come and said you have to do it in this way, but I'd say that the regulations that are coming and the targets that are coming are leading us there, if that makes sense.
Okay, so there's going to be some changes and possibly opportunity in that space as well. Will, are you seeing that at the international level? You sort of mentioned there's opportunities for sensors and monitoring and remote work, but in the monitoring and sensors, is any of it going to be around methane emissions and or other reduction of emissions from different plants? Is that an area where you see a lot of innovation potential?
There's a lot of focus on that right now. The carbon, both the CO2 and the methane management is an area that companies are interested in because they are trying to reduce their carbon intensity. There are international consortia working on that, and some of the big industry consortia like IPCA and things like that, the large multi-country, multi-company consortia that spend research and development dollars and such are looking at these areas. So the technologies, the options for particularly methane and other remote monitoring have really advanced. So now you have multiple layers, everything from devices at say the well site or production facility, to drones and autonomous inspection, to satellites, to light aircraft, and then all the way up to satellite, each with different types of sensors and such. And those are all being developed and commercially deployed as both companies and host governments try and get a much tighter handle on just what they're emitting and where they're emitting it so they can control it. I mean, it is unfortunate that in our industry, the hydrocarbon energy industry, we've had a tendency to waste so much methane through either venting or flaring or what I will call fugitive emissions, because of course it's a valuable resource as well as being a potent contributor to potentially to greenhouse warming as a greenhouse gas or a Tyndall gas, depending on how you like to define it. And that's an opportunity, a significant opportunity for the industry to reduce its emission footprint, and at the same time to recover valuable resources. And so companies are trying to work more aggressively on that. And some of it, again, depends on the host governments and whether they are tolerant of a certain amount of methane loss and slip, or whether they drive a high standard of performance. And as you point out, when there's a strong pain point, I prefer the term pain point. It's a little less graphic than the one you use. But when there's a strong pain point, your driver, the companies will respond rapidly in terms of testing and implementing new technologies.
Okay, so there is a little bit of innovation, and it is kind of, again, a little bit being driven on the regulatory side is what I'm hearing there for what needs to be monitored, and it's not so much a cost driver, but it's good that the regulation is changing and driving some of that innovation. All right. Okay, everybody. Thank you for coming back. I believe my esteemed colleague, Nisha, is going to share a poll with you quickly to see how, what you liked about this. It will stay up so you can kind of answer what you kind of thought there. I will bring up that we will have another edition of the Climate Connections. This next one is going to be focused on the built environment, right? There's lots of challenges. Obviously, yes, the built environment and buildings take about 20% of the energy. And Will was quite right to say, if we can use the energy more efficiently, right? If we just use less energy, all of these problems get a little bit easier. And so I think that's what we're pushing all those retrofit and new builds and sensors and building automation to do, is to just use less energy in the first place. Which is a weird thing to hear people in the energy space kind of going like, yay, if you just use less energy, all our lives would be easier. But that's what we're looking for the built environment to do. Do join us, or recommend that to anybody you think would be interested in that space. I'll say thank you to Jack and Will once again for taking some time out here today to kind of share what it is you're seeing on the other side of the fence of where there's real opportunities that innovators need to be focused on. And I'll finish off with one of my favorite quotes. Will, it might be new to you, but there's this guy called Wayne Gretzky. And he used to say, you got to skate to where the puck is going to be. And so I think that is one of the things that we are really trying to push here, is that look down the road and say, where's the opportunity going to be in a few years' time? There's another little Canadian innovator that I know, and he amends that to say, don't skate to where the puck is going to be in the next period, right? And so that's why there are, yeah, you can sort of say this is what's going to happen in 2050, but what is happening right now where you can commercialize a solution and make an impact on the GHG emissions of the world. So thank you all for coming today, for listening in, and for the good work you do in promoting innovation and promoting some of those solutions. I'll see you all next time.